Hi all, I wanted to share a quick video with you over the equation for calculating average atomic mass, and I also want to do a practice problem with you. I've been getting a lot of questions, so I thought it might be helpful if we take the time to walk through this together. To make sure that you are ready to follow along with this quick video, make sure that you have a piece of paper out in front of you, a pencil, a calculator, and also a periodic table. And I have posted a link to our class's periodic table on the homepage of our Schoology course. So you can either use that link or you can just look up any periodic table online because any of those will also suffice for this practice question. So to start off, let's talk about what average atomic mass is. It is what it sounds like. It is the average mass of all of the isotopes for a particular element. Now, different elements have different numbers of isotopes. For instance, lithium has 3 isotopes, but there are elements like palladium that have 12 or more isotopes. And we have an equation that we can use to calculate the average atomic mass for each of the elements. So at this point, if you don't have your materials yet, I would pause the video and go collect them and then resume the play button as soon as you're ready. Okay, now I'm assuming that we are ready with a paper, pencil, calculator, and a periodic table. So why don't you follow along with me as I write out this equation. We'll start off the equation by writing on the left-hand side, average atomic mass. And it is in units of AMU, which stands for atomic mass units. Now, when we calculate the average atomic mass for an element, we have to factor in important pieces of information about all of the isotopes that it has. One of the important pieces of information is the mass of the first isotope. And we're going to multiply that by the percent abundance. I'm just going to put abun for short. But the percent abundance, and what the percent abundance is, it is how commonly occurring that isotope is. The higher the percent means the more commonly occurring it is, and the lower the percent means that the more rare it is to find that particular isotope. So since the mass and the percent abundance here both pertain to our first isotope, we're going to label this isotope number 1. Now, if we're calculating average atomic mass, then we are going to be calculating elements that have 2 or more isotopes. So we need to add in another isotope. So I'm going to do a plus sign, and then I'm going to do the exact same thing, but for isotope number 2. So I'm going to take isotope number 2's mass times its percent abundance. And I'm going to label this isotope number 2. Now, we may be asked to calculate the average atomic mass for elements that have more than 2 isotopes, in which case all you would have to do is add another plus sign and then add in the mass and the percent abundance for any additional isotopes that there are. Excuse the bell, sorry. Now, the last thing we need to do for our equation is we're going to divide everything by 100. Okay, so I'm going to go to the next page then, and we are going to use this equation to plug in information for a practice problem. So here's our practice problem. It says determine the average atomic mass and then the element's identity. So we have 3 isotopes here. We have isotope number 1, isotope number 2, and isotope number 3. And we have no idea what element these isotopes are for. So we're going to have to calculate the average atomic mass, and then we're going to have to look at the periodic table because the periodic table lists the average atomic masses for all of the elements, and we'll be able to figure out what element this is that we have in front of us in the table. So let's go ahead and start plugging in the information given to us in this table. So I'm going to start off with writing average atomic mass. And you'll notice that as we start putting in the information for isotope number 1, we have two masses here. We've got the mass number listed here, which is really just the mass that is rounded to a whole number. Remember that the mass number is the protons plus the neutrons. But we also have an exact weight. And it's exact because it's not rounded, it is in decimal form. It's more specific. If ever you're given a more specific mass, go ahead and just use the more specific mass. So we're going to start with that. We're going to put 27.9769, and I'm going to include a unit here. It's a mass, so I'm going to put AMU. And then the percent abundance for this first isotope is 92.23, which means of the three isotopes here, the first isotope is definitely the most common. It's the one we're going to encounter the most often because its percent abundance is so much higher than the other two isotopes. So this is all for isotope number 1. All right, now let's add in the information for isotope number 2, and I'm going to have to drop down a line since I'm running out of room. So isotope number 2 has a mass of 28.9765 multiplied by its percent abundance, which is 4.67. And then I'm going to add it to my third isotope, which has a mass of 29.9738 times its percent abundance, which it is the least commonly occurring isotope because it only occurs 3% of the time, which means of all of the atoms out there for this particular element, only 3% of them have a mass of 30. Okay, and then you're going to want to remember to divide all of this by 100 to get your final answer. So at this point, go ahead and pause the video, plug in these numbers into your calculator, and write down what your final answer is for the average atomic mass. And remember that the average atomic mass will be in units of AMU for atomic mass units. Okay, at this point, you should have your answer. And what we can do now with your final answer is we can pull up the periodic table and we can search all of the average atomic masses listed on the periodic table to see if your final answer matches any of them. And again, on the periodic table, the average atomic mass is going to be the decimal number in the element box on the periodic table for all of the elements. So go ahead and scan the periodic table now and see if your number matches any of them. You should see that your number matches silicon's average atomic mass because your final answer should have been 28.085. Now you can see here that the average atomic mass, like I said before, is the decimal number that is listed in the element's periodic table box. So this is the average atomic mass. This is not to be confused with the whole number. So silicon has a whole number of 14. This is called the atomic number. The atomic number is the number of protons in the atom. So all silicon atoms have 14 protons. It's important to notice that silicon's average atomic mass is 28.08, but none of the isotopes had an exact mass of 28.08 because the average mass is not the mass of one isotope, but rather it's the average of all of the isotope masses combined together, with also taking into account how many and how prevalent each of the isotopes were. And what I mean by that is this is a weighted average. So that means that isotopes that are really commonly occurring are going to be weighted more in the average than isotopes that are very rare. I hope this helped. If you have any questions, don't hesitate to send me an email. Thank you.